All right, so this is the last day of Unit 5. It's just kind of a wrap-up on the different type of word problems we've worked with rational functions. So it should seem like a review, because it is. So the first question says, it costs a company $8 to produce a can of paint. If the initial investment in the production line was $50,000, how many cans of paint must be produced so the average cost per can is $10? So when you read here, we want the average cost per can to be $10. So that's like the first type of problems we set up for this unit with rational functions. So we can set up a cost equation. So we'll say the cost of the paint can, of each paint can, will be, we have this initial investment plus $8 per can. That's going to give us the total cost. We want the average cost, so that's why we divide by X. So you remember probably doing that on the first half of Chapter 5. So this is going to give us the cost per can of paint. And the goal is we want to know how many cans of paint must be produced, so the average cost equals $10. So we want to set this equal to 10. Okay, so there's the equation we want to solve. We can see we have a rational equation. I'm just going to multiply both sides by x. So that gives me 10x equals 50,000 plus 8x, because this x cancels. And then I'll subtract 8x from both sides. And that's 2x. Getting ahead of myself there. And then we will undo the multiplication by dividing, and that means that we must produce 25,000 cans of paint to get the cost to $10 per can. All right, so we have two painters, painter A and painter B, can paint a room in 10 hours when working together. Painter B works twice as fast as painter A. How long would it take each painter if they worked alone? So if you think about how we did this on Friday, we would have had the rate of painter A times time of painter A plus rate of painter B times time of painter B, and that's going to equal one job. Now that job is painting a room. Now notice it says that they work together for 10 hours. So both of their time is actually going to be 10. And now what we have to figure out is, what is their rates? Okay, so we know that painter B works twice as fast as A. So if they did it separately, we know that painter A is going to take painter A twice as long, right? So if you think about that, if we let X equal painter B's time when working alone, then 2x is how long it's going to take painter A. Okay, so if you think about this, it says painter B works twice as fast. So that means painter's A time will always be double painter's B. So if like the painter B can do it in 12 hours, it's going to take painter A 24 hours. Or if painter B can do it in 15 hours, painter A is going to take 30 hours. So we need to figure that out. So when we think about the rate at which painter A is going to work, you have to think his hours is 2x. So that means he can finish 1 over 2x room per hour. And then if we look at painter B, if he can finish the room on his own in X number of hours, that means he can finish 1x of a room per hour. So that would be his rate. So there's our equation. We can get a common denominator if we want, depending on how you want to solve this. If I do that, this needs to be a 2, and this needs to be a 2, and this needs to be a 2x, and this needs to be a 2x. So at that point, we have 10 over 2x plus 20 over 2x equals 2x over 2x. So if you want to solve it that way, we can. And then what we're left over with is 10 plus 20 equals 2x. I'll divide by 2, and x equals 15. So what that means is that painter B would take 15 hours if they worked alone, and painter A would take 2 times that amount, so that would be 30 hours. So obviously working together here, they can do it in 10 hours, so that would be obviously the faster rate, or faster way to go. All right, so then you guys have worksheet 16. I think it just has 3 problems on it. Little of each type of rational word problems.